Hi, and welcome to lesson 2.6, which involves solving inequalities. So for this lesson, we're going to be looking at some ways to solve the graphs of inequalities. And in this case, we have a polynomial function here. And just like if we were solving for an equality, what we're going to first want to do is set this equal to 0. So in order to do that, I'm going to subtract 1 from both sides. And on the left side, I get x squared minus 8x plus 15. And on the right side, 1 minus 1 is going to give me 0. So the next thing I'm going to want to do is factor that trinomial, and two numbers that multiply to give me positive 15 and add to give me negative 8 will both need to be negative, and those would be x minus 3, so negative 3, and negative 5 with x minus 5. So that means if this were an equality, my zeros would be positive 3 and positive 5. So what I'm going to do is set up what's called a sign chart from negative infinity to positive infinity. And I'm going to put my zeros on the chart. So I have a 3 and I have a 5. And now what I need to do is come up with some test values to try between each interval on my sign chart. So between negative infinity and 3, the easiest test value would be 0. Between 3 and 5, let's go with 4. And then from 5 and beyond, I'm just going to go with 6. So what I do is I put my test value into my two parentheses. So I get in for x, so I get 0 minus 3 and 0 minus 5. And I don't even have to solve these for a value. I just have to determine whether it would be positive or negative. So 0 minus 3 would be negative. 0 minus 5 would also be negative. And when I multiply those together, I get a positive. So in this part of my interval, it's positive. Now let's test 4. So 4 minus 3 is positive, and 4 minus 5 is negative. A positive times a negative is a negative. So in this interval, we have a negative. For 6, we do 6 minus 3 and 6 minus 5. We have a positive, and that's going to give me a positive when I multiply them together. So in this interval, we have a positive. So now here's the key. What we want to do is we want to determine whether we have a less than sign or a greater than sign. If we have a less than sign, the intervals we want to look at will be the negative intervals, which in this case would be from negative 3 to, positive 3 to 5. And then if this were to be a greater than, my intervals of interest would be negative infinity to 3 and also 5 to infinity. So in this case, since our sign is a less than, we're going to use the interval negative 3 to 5. I keep saying negative. It's positive 3 to 5. And that's going to be my interval over which this inequality holds true. So here's an inequality for you to try on your own. Notice that as B and C show that you could have two intervals, or as A and D, like the problem we had before, you could have one interval. So see if you can figure out which that would be, and then you can go ahead and move on to the next tutorial.